Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Fakir bin Syarul Zaman. I'm a team leader for group. So this is a group member, which is first is Izra Syuris Azril bin Syukur, and then second one is Aziz Zikri, third one is Zul Iskandar, and fourth is Muhammad Mishdar Hakif. So our group will present about first is objective and introduction. The second one is problem. So third one is literature review, and then fourth pseudocode, and then flowchart, and then user manual, how to use the Python, and then lastly is result. Then we have some conclusion from based on the Python data. So first is Python is a versatile and widely using user programming language. Van Rossum in the Netherlands. So Python is replaced the ABC language. Programming was inspired by SETL. So exception handling and compatibility with the mobile operating system. So we have three objectives, which is to develop a Python program related to mechanic and material cost in civil engineering. So second one, calculate the reaction force RA and RB by using static equilibrium, aquatic method, and interval force in the member of the truss ABCD. So number 3 is to use appropriate technique and skill by refer by PDLC steps when creating Python program.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zul Iskandar bin Zukiman, CF220214. Now I want to explain about the literature review. So as you can see at the slide, for figure 1 is our beam. So beam is a structural component which longitudinal axis that span between a support and provide support to transverse load that effectively combat internal stress like load, bending and shearing. So the figure 2 shows that a simply supported beam. For figure 2 is simply supported beam. A simply supported beam is a common type of beam that has a pin movable support at one end and a roller at the other end along the same axis. This allows rotation and vertical movement but not horizontal movement at the support. Right. For the beam, we have three types of the support for beam. So first is a pin support, second is a roller support, and three is a fixed support.
Assalamualaikum, and I'll be talking about the flowchart of our program. First of all, the user will have to enter their details, name, ID, date, and then we will display the instructions. Our program will display the instructions, which is define max numeric value and max iterations. From this, the user will enter the number of spans. If there are 3 spans, then the user will write 3. So we will validate the loop here again, and if it's an error, the value must not exceed 1000. So and then we will enter the span details, such as the length of the span, and then the fixed end moment for the span, the stiffness factor, the carryover factor. After that, from the number of iterations, we will validate with a loop. If it's an invalid, the user will enter the number again, and if it's a valid, we will call for the moment distribution method, and we will initialize the moment array. From this, there will be another iterations loop to calculate each iterations available. So if there are 10 iterations, then this loop will be repeating 3 times until after all the iterations are complete. We will print the final moments of the beam. And that is all for our flowchart. Thank you.
Okay, next is my name is Izra Syuris Azril bin Muhammad Syukur, and my metric number is CF220237. I want to explain about how to use this program, yaitu user manual. So first of all, step 1 is we must to enter the users details. So we have a engineer's name, engineer's ID, and date. And step 2 is we must first of all, to calculate the moment distribution method, we must enter the number of span. Okay, next adalah step 3, iaitu to continue to calculate moment distribution, users must enter the length of span for each span, which is span 1, span 2, and span 3. And step 4 is user have to enter the fixed end moment also for each span, which is span 1, span 2, and span 3.
Hi and Assalamualaikum everyone. My name is Muhammad Miftal Aki bin Muhammad Zahir, and now I will be presenting the step 5 onwards for our project. So on step 5, we have to enter the stiffness factor for each of the span. Stiffness factor is the value of K. And for step 6, we apply the carryover factor, or otherwise known as the distribution factor. And for the step 7, we enter the amount of iterations for our calculations. This should be more than 5, and the usual value is 20. And finally, for step 8, after we did enter all the parameters, the code will show us the data up until the number of iterations, and the code will also summarize and add all the moments value for the iterations, and from that we can enter that inside the Excel or straight away do the bending moment diagram and the shear force diagram. And finally, for the conclusion, this report presents a Python code for structural beam analysis using the moment distribution method. It is a classical structural analysis technique. The code is user-friendly and efficient, allowing users to analyze and visualize beam behavior under different loading conditions. The key components include a user-friendly interface, data processing, iterative moment distribution iterations, comprehensive results, and graphical visualizations. The accuracy and reliability of the code are validated through comparisons with theoretical solutions such as using Excel and benchmark examples. The report concludes with an overview of the successful implementation and potential enhancement, offering a valuable tool for structural engineers and students. So that's all for our group. Thank you very much.